So things to keep in mind, we are wrapping up our quarter. We have less than 2 weeks left. Our quarter actually ends next Thursday. You don't have school on Friday. And so you want to make sure that you have the things that you need, that you're getting things taken care of, that you're doing what you need to do, that you are just all of the pieces that you can be getting those things taken care of. So as you're doing that, all of your quizzes are open, practice problems, labs, those pieces are still available and can still be submitted. I'm not taking off any penalty for having it be late. So if you have a lot to do and you're in a spot that you can do it, do it. Keep moving forward, every single piece of it. If you have questions, let me know. I have office hours tomorrow from 1 to 2, and on Friday from 11:30 to 12:30. Yes, that's what time it is on Friday. So use those well, communicate with me, let me know what you need, and we'll keep moving forward. One more thing. I don't know. I'm going to share my screen with you. And maybe it's thinking. Everything's a little bit slow today, so I'll just do it. My screen froze last hour, so that was super fun. All right, I'm going to grab my marker that I dropped. I spilled water all over myself this morning, so that was fun. We're just sort of off to a good start. But I'm obviously in my classroom, and I'm cleaning out stuff that I think was here when the building opened. Like some of this some old physics equipment. Pretty sure was, and now we have stuff that is more compact and can do what we need to do. So it's not worth keeping the equipment around. But man, it's old. It's real old. Like I said, pretty sure it was here when the school opened. All right, let's talk about waves. We're moving into talk about waves, where we've got a bunch of different kind of pieces that we're going to do with that. And what happens with waves is that we have, it's enough that we normally go about a week and a half on it, which works incredibly well for the end of the quarter here, because you won't quiz on this Thursday. I'm going to introduce some pieces of it today. I'm going to introduce the calculations of it on Thursday, and then we'll wrap up and you'll quiz next Tuesday. So we are absolutely moving forward with the things that we need to do, and we should be in good shape. So let's do this. We're talking about waves. And when we're dealing with waves, it's energy that's being sent through a medium it disturbs the medium, but it doesn't take it with it. When we talk about a medium, it's just anything like air, any gas, any liquid, any solid, anything that can send that wave through it. The only time we don't have a medium is when we have a vacuum. I'm not talking like a Dyson. I'm talking like when we take all of the air particles out of a space. And then that's the other thing, as we experience that in space as well. And so that's the only time we don't have a medium. So when we say medium, we're just saying anything that a wave can travel through. So energy. And we've talked about energy before. In this case, it happens to be sent through as a wave as opposed to other forms of energy that we've looked at. It's sent through a medium. It disturbs the medium, but it doesn't take it with it. It doesn't take it along. And so it's kind of this, so think about this. So this is how we experience waves. We experience a lot of different waves, but one of the ways that we can experience, think about this, it is nearing the end of March here. So we're getting closer to summer. We had the vernal equinox this weekend, so we're into spring, so it's bringing us closer to summer. So think summer for a minute. And you are enjoying an awesome summer day out on an inner tube. Here you are, there's your legs and your arms and a big smile because you're sitting on an inner tube in the middle of a nice lake, lots of sunshine, you're just hanging out. And a little bit out from you, a boat goes by, and a boat has a wake behind it that causes some waves. Well, you're sitting here, shore's over here, and the waves start coming across this way. And so the waves come like this, and they get to you. And when they get to you, for a moment, you'll go up and down, and then those waves will continue on past into shore. So as somebody sitting on the medium, you are disturbed by going up and down, but you don't go along with the wave. The wave goes through the medium of the water. The water is disturbed and moved up and down, therefore you are moved up and down. But then that wave and that energy that goes along with it continues into the shore, and you go back to just resting on the top of the water. So that's what we talk about with the idea that it disturbs the medium, but it doesn't take it along. If the wave took all the water with it, the wave would come and it would take you and everything else, and like whoop, the whole thing will go into the shore. You'd go into the shore and be like, oh, I can't have a wave. Reality is the energy goes through the medium and gets it to the shore, but the water itself stays relatively put. Screenshot that if you would like. I'm going to be moving on in just a moment. There we go. We have two types of waves, two main types of waves that we use that we'll be focusing on. There are kind of some other types that are mostly a combination of those, but the types of waves that we have transverse wave and we have longitudinal wave. So a transverse wave is probably what you think of the most when you think of a wave. And I'm going to kind of give you a technical definition of this, and then I'll draw it and talk about it and help it make sense. And with a transverse wave, the wave travels perpendicular to the disturbance of the medium. The wave travels perpendicular to the disturbance of the medium. What does that mean? What it means is if we watch the wave and we see the wave coming this way, it means that the medium's going up and down. So in the example that we just talked about with being in an inner tube sitting on the water, the medium went up and down and the wave went to the side. We draw this something like this, where we would have it go up and down and up and down and up. We go up, oh, too high, and down. And down and up and down, down and up, like that. That is a very poorly drawn transverse wave. These should not be as low as they are. And so, but the transverse wave, the wave moves, let me just change color real quick. The motion of the wave is up and down. Or the motion of the medium, the disturbance of the medium is up and down. The motion of the wave travels side to side while the motion of the wave is up and down. So the wave travels perpendicular to the disturbance of the medium. So this is going up and down, perpendicular to that is at a 90-degree angle, and the wave travels that way. So if we saw this wave going, we would just see it moving across the page. If we were inside of the water, let's say it's water, we would watch the water going up and down. The other type of wave is a longitudinal wave. So if you want to take a picture of that, go ahead and do that. I'm going to shift up and draw a longitudinal wave. I'll write this here. I'll move in a second. This is also known as a compression wave. So longitudinal wave, compression wave can be used interchangeably here. With the longitudinal wave, we'll use the same verbiage that we have here up above. We said that the wave travels perpendicular to the disturbance of the medium. In this one, the wave travels parallel to the disturbance of the medium. The wave travels parallel to the disturbance of the medium. This isn't one that we can draw it, and we're going to draw it. This is probably going to be the only time that we draw it, because the way that we draw it really doesn't give us much information. It's more of a conceptual understanding of what's happening. So we talk about a longitudinal wave, and we say that it travels parallel to the disturbance of the medium. That means if the medium's going this way, it means that if the wave is going this way, it means that the disturbance is going back and forth. And so we draw this like this. And we have areas that are really tight and then areas that are really loose. And you think about a slinky, and a slinky can go and sort of, if you slide it back and forth, it gets tight and then goes ahead, and then tight and then goes ahead, and then tight and then goes ahead. And what happens here is it compresses here, and then it kind of compresses like a spring and gets energy there, and then it releases it across. And so what you would look at is you would just see the shifting back and forth and back and forth. And so the medium itself just kind of oscillates back and forth. It goes out and back and out and back. And what you would see, what you would view, is the wave moving that way. So we would say that our wave motion is going that way, and our medium itself is just going back and forth. So instead of going up and down like we have in a transverse wave, the wave motion goes back and forth like this. And so it gets crunched up here and releases and crunches up there, and releases and crunches back here, and releases and crunches up there, and it goes back and forth. So these are our two types of waves that we'll be focusing on. They can work in conjunction with one another, and there's kind of different ways that we might experience waves, but this is how we're going to look at it and break it down in what we're doing. So if you want to screenshot that, go ahead. If we talk about baseball. I really like baseball. I like watching baseball. I like Major League Baseball. My husband actually used to work for the Twins in the minor league system. So all the guys on the team right now were actually playing back like in their rookie seasons and A and AA and that sort of stuff. They were making it through their minor league stuff while he was doing that. And so I have watched a lot of baseball. I actually got to see Byron Buxton's first at bat when he entered the minor league system with the Twins right after he signed. Watch Sano play. I don't know. It's just super fun. And it's particularly now knowing some of those, not knowing them, but having watched them for such a long time, it's really fun to see when they're being successful. So I love baseball from a physics standpoint. I love the wave. From a personal standpoint, I do not love the wave. I do not like when someone tells me to stand up and yell and scream. That's just not me. And so if someone's saying like, let's do the wave, for whatever reason, it ends up being like at my section that they want to try and start it. And I'm like, oh, not my thing. Now I can appreciate a good stadium wave if it is a full stadium and the thing's actually going. And if that happens, it's actually really cool to see. But in the wave, a stadium wave is a transverse wave, because the people are the medium, and the people stand up and sit down and stand up and sit down. So the disturbance of the medium is up and then down. But you, as a person in the stadium, you watch the wave move side to side around the stadium. And so you can see it coming. You see it coming, you're like, oh, here it comes. Oh, it's not dead yet. Here we go. Ah! You haven't moved anywhere. You stood up and you sat down. You are still in your seat. But the wave itself is moving sideways around the stadium. Again, if it's a packed stadium, everybody's doing it. It's really cool to watch. If I'm trying to start it, I'm not a fan. Now, what I would be a fan of is getting a packed stadium and convincing everybody to do a longitudinal wave. You could do this. It would look amazing. And what you would have is, instead of going up and down, everyone would lean and sit back up. So that longitudinal wave would be coming, and you'd see it coming and be like, oh, lean, sit back up. And you could watch it go around the whole stadium. It's a little bit more subtle because the motion isn't as large, but you would see the whole section lean and sit back up, and then the next section lean and sit back up, and you would see that longitudinal wave. I would be much more a fan of that. I feel like there's less hollering involved when that happens. So these are the two types of waves that we're talking about. Hopefully you have a little bit of an idea of how they work together and how we might experience them. The next thing I want to talk about is how to draw like the different parts of a transverse wave. We won't draw out a compressional wave because it's not something that's going to be helpful for us. But a transverse wave can be really helpful for what we're doing. And so I'm going to draw and label the parts here, and then in the last bit of time, we're going to practice drawing a few of them together. So if we draw a wave here, like this, I'll draw this one correct this time. Put my kind of resting point here. If there's no wave going through it, this would just sort of be the resting point. 1, 2, 3, 4. Let me get this. Because I have graph paper, we'll make it look real nice. There's 1, 2, go right to there. So each time we're going to go down 3 and up 3. 3, down 3 and up 3. And so this can get real technical in how we're getting this set up. But when we're using graph paper, we can get it to look nice and even. And so there's some different things that are happening here. First of all, this is a transverse wave. And anytime, even if we're dealing with if we're dealing with a compressional wave, it'll frequently still be written as a transverse wave because it ends up, that's what will help us see what's going on. And so as we're looking at that, like sound is a compressional wave, but if you look at a device that's measuring sound, you'll see it as a transverse wave. So there's some different pieces that we need to look at while we're doing this. First of all is the distance from the start of the wave until it starts to repeat itself. And this is going to be our wavelength. And it's represented with a lambda. It's an upside down Y, it's a Greek letter there. And so you have that, and that's the length. It is a length, so it's still measured in meters, and it's the distance of one complete wave cycle. So wavelength. And you've probably done this in math. If you took 9th grade science here, I can guarantee you did this in 9th grade science. But it's just sort of a baseline of some of the things that we need to know as we're moving forward here. Wavelength is measured in meters here, and it's the length of one complete wave cycle. So if you follow this, you start here and follow it this way. Once it gets here, it starts repeating, and it would be a new wavelength. So in this one, I have 3 wave cycles that are actually present here. Write that here, 3. So in this one, I have 1, 2, 3 wave cycles that are present, and each of them have a wavelength of, if I count boxes, 1, 2, 3, 4, 5, 6, 7, 8 boxes. 8 boxes each. And I'll show you kind of how that plays into your drawings in a little bit. Another piece that you have is your amplitude. Your amplitude is how high up you're going from your resting point of that medium. And so it's the farthest point away from the resting point, and it can be up or down. It's the same for both. So in this situation, I have an amplitude of 3 up, and I have an amplitude of 3 down. And you would always have the same up and down. So I just say my amplitude is 3. So when we say amplitude here, it's also measured in meters, and we actually won't use it in a calculation. It'll just be that it's a kind of a conceptual idea that goes along with it. When we talk about a larger amplitude, it means it has more energy in that wave. So if you just have a little wave coming through here, it doesn't have as much energy. If you have a big wave coming through here, you have a lot more energy that is going through that medium. And so it's the farthest distance from the resting point. And so we talk about that as our peak and our trough. P-R-O-U-G-H. So the peak is up here. Trough is down here. And so those are the main pieces that we have when we're looking at our waves. And so here we would have our wavelength is 8 boxes. Our wave height, our amplitude here is 3 boxes. And we have 3 wave cycles that are present. So if you want to take a screenshot of that, go ahead. And then I'm going to show you kind of one of the things in some of your practice problems this week. Again, your practice problems won't be due till Tuesday. But you have one set that's drawing and one set that's calculating. And so this will go along with your drawing set. Try it again. In the practice problem sheet that has waves for you, it'll give you the grid like you have on the graph paper here. So if we do this and we say, let's say we're going to have a wave and we're going to say that the wavelength equals 6 boxes. We're going to say that the amplitude equals 2 boxes. And we're going to say that we have 2 wave cycles. So you will get some like this, where it tells you what your wavelength is. It tells you what your amplitude is. And then it tells you how many wave cycles you have. So the first thing you'll need to do is figure out how long your wave is actually going to go. Because a lot of times you'll have extra space available after that, after your wave. Not always, but sometimes. So I've got 6 boxes and it's 2 wave cycles. So I'm going to set it up here. I'm going to go 1, 2, 3, 4, 5, 6, and I'm going to put a line there. That'll be 1 wavelength. 1, 2, 3, 4, 5, 6, and put another there. That's as far as my wave is going to go. I'm not going to do the whole page. I'm just going to do what is listed here. So 2 wave cycles, there are 6 boxes. Now remember that it's the entire wave that we're talking about here. So the whole thing, both the top part and the bottom part. So that means that the wave is going to need to cross halfway through. So I'm going to take and just put a dot halfway between these dashes here. So 1 wavelength is 6, but I'm going to go to 3 and put a dot there. And then my amplitude is 2 boxes. So when it goes the highest part away, it'll be 2 boxes up. And when it goes the highest part down, it'll be 2 boxes down. So then I can draw my wave. I'm going to go up like this and come down. That's half of it. And down and up. That is my whole wavelength there. And I need 2 wave cycles, so I'm going to do that again. Same thing, I'm going to go up here, come down, go down here, and come up. That would be how I would draw this wave. So the pieces that I know here, I've got 6 boxes for my wavelength. That means the entire wave is in those 6 boxes. My amplitude is 2, so it goes 2 up and 2 down. And I have 2 wave cycles. So there's 1 wave cycle, and there's my next wave cycle. So that's what we have for that one. Let's do another one. Let's say, I don't know, let's do my amplitude or my wavelength equals, well, let's go 8 boxes. And we'll say that my amplitude equals 3 boxes. You could use boxes, you could use centimeters, you could use inches, you could use any type of measurement that's consistent with what you're doing. If you're doing this on notebook paper, you can just, for the amplitude, you can use lines on your notebook paper if you want, that's fine. And we'll go 3 wave cycles. So first of all, we have to figure out how long this line goes. And so we've got 8 boxes for 1 wave for our wavelength. We've got 3 wave cycles. So we're going to go 24 boxes. I think that should fit here. Yeah, it will. Okay. So we're going to go, I'll start here. I'm going to put a line of where I'm going to start, and I'm going to count out this way and go 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. And put a line there. 1 full wave cycle will go in there. 1, 2, 3, 4, 5, 6, 7, 8. Another full wave cycle will go in there. 1, 2, 3, 4, 5, 6, 7, 8. Another one in there. So that will be my length that's going through there. It'll go like that. And then my amplitude is 3 boxes. So that means I'm going to go 3 boxes up and 3 boxes down. And then I also have to remember that the entire wave goes within our 8 boxes. So I'm going to go to the middle here at 4. 8 divided by 2 is 4. I'm just going to put a dot there so I know where I'm crossing. Halfway, 1, 2, 3, 4, halfway like that. So now I'm going to go ahead and draw my wave. I'm going to come up all the way up here. I'm going to go 3 boxes up and down. I'm going to go 3 boxes down and then up. I'm going to do it again because I have 3 wave cycles. 3 boxes up and then down, 3 boxes down and then up, and then my third one, like that. And so that would be my wave that meets these requirements. My wavelength is 8 boxes, so from the beginning to the end of a cycle is 8 boxes. I've got an amplitude of 3 boxes, so it's going up 3, it's going down 3, and I've got 3 wave cycles. There's one of them, so there's the first one, second one, third one, like that. So if you want to take a screenshot of that, awesome, I got both of them in there. You can do that. So again, just sort of in review of what we're working on, you'll have 2 different kind of practice problems and a lab. So you have 3 different formative assignments. You have a quiz that you'll take next Tuesday, and then that'll be it for the quarter. So 3 formatives and a summative left. The last couple days of the quarter we'll use to make sure that everyone's in good shape for wrapping up and ending the quarter well. So that's kind of where we're at on those things. So keep moving forward. Keep doing the things you need to do. Keep getting things in. Keep moving forward. Remember that you want to make sure that you're targeting to get yourself passing so that this doesn't kind of drag you down as we move forward into other things. And we'll just keep doing what we're doing. So I'm going to hang on if you have any other questions. Other than that, have an awesome day, and I will see you on Thursday. Bye-bye.